All right, class, we're going to go through examples number 3, 4, and 5 on the second video. Examples 3 and 4 seem pretty easy compared to the first two examples. And then the last example, example 5, is just another Ferris wheel example. So something you've already seen before, maybe just a little bit more in-depth questions at the end. Okay, so first example, it says an anchored barge bobs up and down with the height h of its transmitter in feet above sea level, modeled by the following function, where t is representing time in seconds. So time is in seconds in this case. That comes back when we actually have the question. So it says, graph your equation over an interval of 1 minute. So here's a huge hint. They said it was 60 seconds. So always be careful. Always check those units. Come test day, this little parentheses might not be there. You would just need to know that your time is in seconds. So you might have to do that conversion on your own at a later date. Okay. So right now it's very similar to that high tide, low tide example where you have a sine wave function. You are starting, 18 feet above sea level and it reaches an amplitude of 12 feet. So just a really rough sketch here. Once again, all my sketches are relatively pretty rough here. So we have our x-axis, which is time, and we know that time is in seconds. And then my y-axis is height, and that height is in feet. All right, so we're starting at a height of 18. I'm just gonna say it's roughly here, and it's going to bob up 12 feet and then back down and then up and then back. And it's just gonna keep repeating. Obviously, it's a sketch. It probably repeats more than this over the entire lifetime of the period here over that 1 minute span. All right, so just a couple of things before I get into graphing this, especially because I want to know the stuff before I start plugging in my window. I'm starting at 18, and from that 18, that midline of this example, I'm going up 12 feet. So right off the bat, I know my maximum height is 30 feet, and then I can also calculate my minimum height from that as well. So it just gives you a general idea of what these values should be. But worst case scenario, you plug in some numbers here, you make it in your calculator, and it doesn't fit, like your sine wave function is off of your window, you just have to go back and readjust this. This is not set in stone. You can change this. Okay, so once again, I like to see the bottom of the ocean floor. So I'm going to make, or sorry, this is my x-axis. I want to see a little bit of time to the left. So I'm just going to make that a -2 just so I can actually see my y-axis. My x maximum, it is over a time period of 1 minute, which is 60 seconds. I'm going to make this a little bit larger, so I'm going to make it a 62. My scale, I always like to just go up by ones. Doesn't really bother me that much. My y minimum, I do want to see that ocean floor, so -2. You don't have to make this a -2. It could be, you don't have to see the floor bottom. You can actually make it come up here. It's just personal preference. And my maximum, I know it reaches a maximum height of 30 before it bobs back down, depending on what those little waves are. So I'm just going to make this like 35. Once again, doesn't really matter. And my scale, once again, is a 1. Okay, going to go into y equals. I'm already in my radian mode, so I don't need to change that. And I'm going to type in my function. So I have 12 sine of 0.676x, close a parenthesis, plus 18. I'm going to go to my window and I'm going to put these values in. So time -2, my x max, have to get that full 60 seconds, so a little bit more than that. Scaling is good. Minimum, I want to see the ocean floor, so -2. My maximum is 35. That's based on where my midline was plus the amplitude. And then my scaling is good. And let's press graph just to see what the picture is. So it does look like I can see the top of my amplitude, and I can also see the bottom, right? That 6 feet is my lowest, right? 18 minus 12 gives me that right down there. And then this is my full length. This is my 60-second time period. So if you can picture yourself on a boat, this is making me feel a little seasick, but you go up and then down and up and then down, right? So this is like you staying on a boat. Like if you've ever tried to stand up on a boat when it's a little rocky, that's basically what this is doing. It's bobbing up and down in the water. That's that full 60-second time period, and that's where the boat level is. So it says how many times during that minute is the wave height at a maximum? All right, so you don't have to do this, but I'm just going to show it to you. If you go to y equals, I know that my maximum height was 30. So if I just type in a horizontal line of 30 and I press graph, I'm basically just going to count all of the intersection points over this time period. So it looks like I have 1, 2, 3, 4, 5, 6, 7. So how many times during that minute is the wave at the maximum height? you can say 7 times. And then if you want to get super specific, reaches a max height of 30 feet. You don't really need that little extra explanation, but it does reach that max height of 7 times. And that's literally all that question is. Just how many times is that boat at a height of 30 feet off the water? I guess off the ground. All right, second question is literally identical to it, just the numbers are changed. So we'll run through this one a little bit quicker. So it says an anchored barge bobs up and down with the height, same exact transmitter and feed, above sea level, same exact sign function, just the numbers are changed, and T represents time in seconds again. And this time the interval is 30 seconds, so it's less time. So when I go through and I draw my really rough sketch here, I still know this is height in feet. And I still know this is time in seconds. It's a sine wave. I'm starting approximately 23.5 feet off the ocean floor, off the midline, right? I'm going up 11.5, so it's just gonna look something like this. I just gotta calculate all of the maximum heights. How many times did it reach that maximum height? All right, so very similarly, I'm going to start with a little bit of negative time so I can see my axis. My maximum in this case is 30, so let's just do a little bit more than 30 so I don't accidentally cut off a maximum. Scaling is 1. And then now I'm looking at my height. I always like to say, I like to see my x-axis, so I make my height a little bit negative. And then I have 23.5 plus 11.5. That would be that maximum height. So just to be safe, let's just do 40, right? It doesn't have to be perfect. It doesn't always have to be a mathematical calculation. These are just approximations. All right, come back over here. Let's go through. I'm going to delete this out because that's not an exact number. If I wanted to, I could do 23.5 plus 11.5 and make that my number. But once again, it doesn't have to happen that way. We have 11.5 sine of 1.31x, close that parenthesis, plus 23.5. And then I'm going to go to my window. That's good. My maximum time is now 30 seconds, so 32 is a good enough estimate there. -2 is okay, and my maximum I said is about 40. Press graph, make sure we can see our full picture here. It looks like I'm pretty good. This is now spanning over just 30 seconds, so I'm okay there. And it looks like I have 1, 2, 3, 4, 5, 6, 7 once again. So I guess the answer is always 7. That was a joke. The answer is not always 7. All right, so good there. Just double checking my math there. So over that 30-second time period, once again, it reaches that max 7 times. All right, so those are two pretty, basic questions there, nothing too crazy. Just once again, the whole part is you being able to contextualize this information and get a actual graph that fits in your calculator in order for you to do some work. All right, last example of the day. We have example number 5. It's one of those Ferris wheel problems, your guys' favorite example, I know. It says a Ferris wheel 158 feet in diameter makes 1 revolution every 214 seconds. The center of the wheel is 85 feet above the ground. The equation below can represent the Ferris wheel, where h of t represents the height of a rider on the Ferris wheel over time t in seconds. So once again, I just like to draw my Ferris wheel just so I have an idea of what that maximum height is going to be. So let's go right here. Decent Ferris wheel. All right, so it says the diameter is 158 feet, so that means the whole length across is 158 feet. And then it says that the center of the Ferris wheel is 85 feet off the ground, so from the center of the Ferris wheel to the ground, let's just say the ground is right here, this is 85 feet. All right, so if I take my diameter, 158, and I divide it by 2, I know that the distance from this point, the center, to the top, I know it's, obviously that's not a radius, but if it was in the center, it would be, is 79. So the full distance from the top of the Ferris wheel all the way down to the bottom is going to be that 79 plus 85, which just real quickly is 164. So my Ferris wheel is a total of 164 feet off the ground. That is going to be necessary for when I'm doing my Y-min and Y-max values over here. Because remember, my Y-axis in this case is the height of the Ferris wheel, And the x-axis, once again, is time in seconds. And I have a period of 214 seconds. Okay, so let's go through and let's figure out what our window is going to be. So time, I always, like I said, like to pick a little bit negative. I know you can't have negative seconds, but I like to see it there. My x maximum, 1 revolution is every 214 seconds before it starts repeating. So let's just go ahead and make this like 220, give ourselves a little bit of room there. Scaling is still 1. Might need to change that because these numbers are kind of big, but let's just check it out. Minimum, obviously you can't go underground, but I want to see a little bit of that x-axis. And then at maximum, the highest you can get is 164. Let's just go ahead and make this 170. Scaling is a 1. All right, let's come over here. Let's go to y equals. Let's type in our function. We have a negative 79 cosine of 0.029x parenthesis plus 85. I'm gonna go to my window, fix all this good stuff. We got 220 as my max. My y minimum is good. My y maximum is 170. And then let's press graph. All right. Oh, got a little close there, but we are in good shape. Obviously, you start relatively close to the ground. You get all the way up to a specific height, and then it comes back down. You guys all know how Ferris wheels work. Okay, so that looks all good. Now let's use this information to help us answer these questions. It says, how many seconds does it take to reach the maximum height? The maximum height of the wheel. All right, so we already decided that that maximum height is 164 feet. You can't get any higher than that. So if I go under y equals here and I type in a 164, and if I graph that, hopefully that is a nice horizontal line that reaches the very top of my Ferris wheel. And if I want to figure out how long it is, I need to find that intersection point. So second trace, go down to option 5. You can always just press enter twice. And then it looks like, my guess, let's just guess, maybe right there looks good. And my calculator says that the maximum point is 108.33, comma 164. So what that means is approximately 108.33 seconds into our Ferris wheel ride, we will reach a maximum height of 164 feet. It looks like, see how my intersection point's a little bit at the very, very top of my calculator? You could also fix that. If you go down here to a y max and you make this like 190, it just makes it a little bit easier to read. That's why it's always, it's easy to go back through and adjust that window for easier viewing instead of it being at the very, very, very top of my screen. Okay, how many seconds does it take to reach a height of 85 feet for the first time? Right, 85 feet for the first time. So if we go to y equals, I'm going to change this 164 to 85. Make sure you delete that 4. All right, and then I'm going to press graph. Should be same picture, except for now instead of it being at the maximum height, it's going to be at a height of 85 feet. And if you notice, it reaches 85 feet once, twice, right? You care about the first time it reached 85 feet. So the exact same calculator keystrokes, press second trace. I'm going down to intersect. I can press enter twice right off the bat. And then I'm going to scroll all the way over here to this first guess, press enter, and I get a point of 54.17, comma 85, which means that it takes approximately 54.17 seconds to reach a height of 85 feet for the first time. All right, last question of the day. It says, what is the height of a rider on the Ferris wheel at 90 seconds? So in all the other cases, they gave us the y value. This 90 seconds is an x value, or technically, in this example, it's a t value because they use t instead of x. So a couple of different ways you can go about answering this question. The first method I could do is everywhere I see a t in my equation, I can plug in a 90. All right, so I can come up here, and everywhere I see a t, I can plug in a 90, and I can just type that right into my calculator, and it's going to give me the height after 90 seconds. All right, so let's go ahead and do that calculation just real quick, and then I'll show you the last method, and then we'll call it a day. So negative 79 cosine of 0.029, and then in parentheses 90 because I'm substituting in 90 for t, plus 85. And you get 153. Let's round this to the nearest tenth. So we'll do 0.1. 0.1, and that is what, feet? All right, 153.1 feet after 90 seconds. Also, what you could have done, since we already have this typed into our calculator, I could go to my table, so I could press second graph. And then, oh, looks like my table set is all kind of weird here. So let's start at 0, and let's go up by ones. And then, so if I go to my table here, I need to get to 90, right? So that's going to take me a while to scroll all the way down. So if you look up here in blue, it says table set. I can press second window, and then I can start my table at 90. That way I don't have to go through and scroll 90 times. So I can press 90 and then go press second graph again, and then now I'm at 90. And if you notice, according to my calculator, it's also 153.1 feet. So a lot of different ways that we can do this. Since we already had it plugged into y equals in our calculator, we could use the table, scroll down to when x is 90, or you could have just gone back up and plugged in. So like some of us are a little bit lazy with our calculator, and we'd rather just like substitute in because that seems easy to us. But either way, it works. So after 90 seconds, that rider is 153.1 feet. All right, guys, if you have any questions at all, please do not hesitate to email me. I'll be posting more stuff tomorrow for you guys. All right, see ya.